Hello everyone, welcome back to the session. This is me Somajit. Let's do a reading comprehension passage analysis. The passage is there in the description. If you want to take a look at it beforehand, you can do that. But if you just want to read it with me, you can do that as well. Let's start with the first passage. The first para says, any universal concept of time must ultimately be based on the evolution of the cosmos itself. When you look up at the universe, you are seeing events that happened in the past. It takes light time to reach us. Okay. In fact, even the simplest observation can help us understand the cosmological time. For example, the fact that night sky is dark. If the universe had an infinite past and was infinite in extent, the night sky would be completely bright, filled with the light from infinite number of stars in the cosmos that has always existed. Now, typically, if you read the first line, you would realize that this is an argumentative passage. That means you are gonna get inference type questions a lot. You can go and see the questions as well, but then you can say this is a sort of a hypothesis that I have. Let's go to the second para. For a long time, scientists, including Einstein, thought that the universe was static and infinite. Static and infinite. Observations have since shown that it is in fact expanding and at an accelerating rate. Okay, it is expanding. It is definitely not static. It is expanding, that too at an accelerating rate. You see, these are your words that you have to pay attention to. This means that it must have originated from a more compact state that we call Big Bang, implying that time does have a beginning. In fact, if we look for light that is old enough, we can even see the relic radiation from the Big Bang, the cosmic microwave background. Realizing this was a first step in determining the age of the universe. So, we are talking about the age of the universe and how actually the universe is expanding. Let's go to the next para. These paragraphs are small, so we'll read them as one. But there is a snag. Einstein's special theory of relativity shows that time is relative. The faster you move the relative to me, the slower time will pass for you relative to my perception of time. So in our universe of expanding galaxies, spinning stars, swirling planets, experiences of time vary. Everything's past, present, and future is relative. Now, this is a very important line, that what is relative? This experience of time is relative. Now, if there is a question that exactly asks me something like this, whether the experience of a idea is there or not, I have to be a little careful. Now let's read ahead. So is there a universal time that we could all agree on? It turns out that because the universe is on average the same everywhere and on average looks the same in every direction, there does exist a cosmic time. To measure it, all we have to do is measure the properties of the cosmic microwave background. Now this is, if you realize what cosmic microwave background, we are again coming back to the idea which was mentioned over there. Cosmologists have used this to determine the age of the universe, its cosmic age. It turns out that the universe is 3.799 billion years old. Too much facts, I'm not really interested. Let's move ahead. There are quite a few paras, so you have to pay attention. So we know time most likely started during the Big Bang, but there is one nagging question that remains. What exactly is time? Do you realize that this passage is totally argumentative? What is time? Alright. To unpack this question, we have to look at the basic properties of space and time. In the dimension of space, you can move forward and backward. Commuters experience this every day, but time is different. It has a direction. You always move forward and never in reverse. So why this dimension of time is irreversible? Again, a question. This is one of the major unsolved problems in physics. To explain why time itself is irreversible, we need to find the processes in nature that are also irreversible. Okay, so in a way or the other, they are trying to, find out an analog through which they can predict the, properties of the other. One of the few such concepts in physics and in life is that time tends to become less tidy. Sorry, things tends to become less tidy as time passes. We describe this usual physical property called entropy that encodes how ordered something is. Okay, this is definitely taken from some sort of a journal or something, or maybe a commentary on a journal. Imagine a box of gas in which all particles are initially placed in one corner, an ordered state. Over time, they would naturally seek to fill the entire box a disordered state, and to put the particles back into the ordered state would require energy. This is irreversible. What is irreversible? This, going back to the ordered state is irreversible. It's like cracking an egg to make omelette. Once it spreads out and fills the frying pan, it will never go back to being the egg shaped. It is the same with the universe. As it evolves, the overall entropy increases. It turns out entropy is a pretty good way to explain time's arrow, and while it may seem like the universe is becoming more and more ordered rather than less, going from a wild sea of relatively uniformly spread out hot gases in early stages to stars, planet, humans, articles about time. You see, this is a, if you realize this thing is a joke, or maybe you can think of it as a humor laid out there, it is nevertheless possible that it is increasing in disorder. That's because the gravity associated with large masses may be pulling matter into seemingly ordered state, with the increase in disorder that we think must have taken place being somehow hidden away in gravitational fields. Hidden away in the gravitational field. So basically, yes, these hot gases and all, they're turning into stars and planets and humans and articles about time, but that does not necessarily mean that this is actually getting in order. It can also mean that they're getting disorder in some hidden alleyway in the gravitational fields. So disorder could be increasing even though we don't see it. So if you realize, this is a way of saying that even though we don't know that, it can still be there. The last concluding state, para. But given nature's tendency to prefer disorder, why did the universe start off in such an ordered state in the first place? This is still considered a mystery. Some researchers argue that the Big Bang may not even have been the beginning. There may in fact be parallel universes and where time run in different direction. Now this is food for thought. Okay, so this is something that typically the author, an argumentative author, will do. They will give you a food for thought. This line is not a conclusion. You can say this was a food for thought. If I were the test maker, I would ask you something related to this thing. Okay, because you can actually go tangentially in this direction. All right, let's go and see the questions. The first question is, according to the passage, the fact that the night sky is dark indicates. The options one by one and see if they make sense. That Big Bang may not have been the beginning of time. Actually, this is something that is written, that the time actually started from the Big Bang because of that cosmic microwave background or the relic of that. So this is something that can be eliminated, that there is a beginning of time as we know it. So we will keep this option on hold for the time being. Light sources are few in our universes. First of all, it is given that the night sky would have been all bright had there been infinite, galaxy, rather infinite stars and infinite expansiveness. It is not, because there aren't infinite stars and all. That is why it is dark. But I cannot say that the light sources are few. Few is a very interesting term, because this directly say that nothing of this sort is given in the passage. So let's go back and check this out once, because it is there in the first passage itself. The fact that night sky is dark, if the universe had an infinite past and was infinite in extent. So what we are talking about is an infinite past. It has existed forever, and the extent of the universe is also infinite. These are the important words. The past is infinite and the extent is infinite. Then night sky would be completely bright, and not because of the devoid. And this is not, dark because there are less number of light sources. So this is actually, tongue twisting the idea goes out. The universe itself has always existed. This is something that the author himself or herself says is not the case. Started off with a big bang. So 2 has to be my answer. Which of the following can be inferred from the passage? Light in the cosmos comes from stars. Well, let's keep this. Time has the same dimension as space. No, space has the dimension in which the commuters can go forward and backward. Time does not allow. Big Bang is not a generally accepted theory. Can you infer that? And if Big Bang is not a generally accepted theory, the passage would have given you hints towards that. Nothing of that sort we have read goes out. The universe is growing larger at a consistent rate. I think we read somewhere that the universe is actually expanding. So if you pay attention to this para, you will realize that the universe is actually expanding, and expanding that too at an accelerating rate and not a consistent rate. So a direct opposite of what is given in the passage goes out. That means 1 has to be my answer, that light in the cosmos comes from stars. Yeah, this has to be the answer. The passage implies that cosmic microwave background. Again, an inference type question. You have to be careful. While ubiquitous is a residue of starlight. First of all, I don't know the meaning of ubiquitous. Obviously, I'm making a video. I can just, do some cheating and check the Google. But I don't need the meaning of ubiquitous. While this is an important word, you can, Google this thing. But then again, not important. While something is a residue of starlight, no, because it is the relic of the cosmic microwave background. This has got nothing to do with the starlight. Is a radiation that pervades the cosmos in a way or the other, is my answer. Maybe I'm keeping it on hold. Cosmic microwave radiation is a proof of the entropy that is the property of all matter. Entropy, they have said, is something related to the disorder of a system. Has got nothing to do with the cosmic microwave radiation, or you can say background. This is in a way also you can say heat. Okay, this is the physicist in me talking, but again, I'm not a physicist, I'm a physics major. But this is the heat, or you can also say the radiation. And entropy is a different thing. Okay, so I'm sorry, this is just to digress a little bit. Yeah. Is a measure of the inherent instability of the cosmos? Definitely not. Is a radiation that pervades the cosmos is the right answer to this question. Let's look into this question. The fact that time is relative to position and speed can imply all of the following except: a human on earth can view a star that is yet to form. First of all, please understand that this is an except statement. Okay. There will be 3 options which are correct and 1 incorrect. Time is relative to position and speed can imply all of the following except 3 correct statement and 1 incorrect statement. A human on earth can view a star that is yet to form. Can a human on earth see a star that is yet to form? Definitely not. This is the incorrect statement, goes away, has to be my answer. All these are incorrect, because again I know I should eliminate, and let's eliminate then. The order in the cosmos is deceptive. Obviously this is given because it is given in the passage that stars and planets and articles on time, one way or the other, is making you think that there is an inherent order. The universe is maybe in one way or the other getting itself into order, but that is deceptive because maybe the disorder is hidden away in some gravitational field. It's written in the passage. A powerful enough device can read the microwaves that microwaves post the Big Bang. Yes, it is true, because this cosmic microwave background is there, so a powerful device can actually read those things. So yeah, this is also true. So this is, because it is true, goes out. 3 correct is not our answer, 1 incorrect is our answer. This is how you will typically choose. Personal experience of time is individual and not uniform. This is also something that is written in the passage, that the length of time is dependent on experience, right? I don't want to go back to the passage. Last question. According to the passage, which of the following could possibly give us a clue to explaining the paradox of order in a universe that clearly prefers disorder? So which would give us a clue that explain the paradox of order? So let's read. The measure of time that is reflected in the cosmic waves such as X-ray and microwaves, the radiation measures from gravitational bodies formed since Big Bang, evolution of notional entities like relative time and relative space from okay, this is a interesting one. The measure of time that is reflected in the cosmic waves such as X-rays and microwaves, these are cosmic waves. X-rays and microwaves are cosmic waves. This is not going to be the answer. The radiation measures from gravitational bodies formed since Big Bang could possibly give us a clue to explaining the paradox of order in the universe that clearly prefers disorder. No. Radiation measure from gravitational bodies will also not give us this thing. The evolution of notional entities like relative time and speed, I don't think. The information that could be gleaned from gravitational field, obviously for obvious reason it is given, because in the last passage, rather last para, it is also written that there could be certain elements hidden away in the gravitational fields, and disorder could increase even though we don't see it, and that could actually tell us or give us a clue to explaining the paradox of order in a universe that clearly prefers disorder. Information that could be gleaned from gravitational field. So this is going to be the answer to that. Okay, so that's it. I hope you understood this well. Thank you.